Everybody, good morning, good afternoon, good evening, welcome. I think this will be the last video I'll do for a while, because after this we've pretty much come to the end of the syllabus on atomic physics, and we'll concentrate a bit more on past paper questions and your understanding of this part of the course, rather than me just giving subject knowledge. Yeah, so we're pretty much at the end. Just before we move on, I've just realised that one thing I've not shown you is this symbol. You're probably very familiar with it from Hollywood movies, especially. It's the hazard symbol for radioactive sources, and you probably realise by now what it actually means. The spot in the middle represents a source of radioactivity, and these bits coming off represent wavefronts. So it's a source giving off waves of presumably gamma radiation. Okay. So just before we move on, we've talked already about quite a few uses of radioactive sources. I'll just cover briefly what we talked about before. But today I just want to give you a few more examples of what alpha sources, beta sources, and gamma sources specifically can be used for. In my experience, what Cambridge is looking for really in your exam questions on these kind of things is for you to link the characteristics of a specific source, alpha, beta, or gamma, to its potential uses. I hope that made sense. I'll just explain that a bit later anyway. I hope that kind of made sense. Okay, so just before we move on to other new uses, just a recap of some of the uses that we've talked about already. This one, obviously. We've talked about nuclear fission and nuclear fusion in terms of bombs. This is the European prototype fusion generator that we talked about before for power generation. Down here, this is a uranium fission reactor, like the one we saw in Chernobyl and other places. These are control rods and fuel rods inside a reactor. And this is a guy that we've seen before. He's doing radiocarbon dating on an Egyptian mummy. So fission, fusion, radiocarbon dating, possibly a few others we've talked about. Let's move on to quite specific uses. Okay, the first one I'd like to do is alpha particles. And as you can see on the list above my head, alpha particles are used in smoke alarms. Not all types of smoke alarms. This is a very specific type. There's one above my head now, actually. I won't take it off the ceiling to show you. So this is quite a nice use of alpha sources. And you probably didn't realise, if you've got a smoke detector in your house, or in our classroom actually, there's a good chance it actually does contain an alpha source. Usually smoke detectors use americium, named after the Americas, americium-241, which is an alpha particle emitter. Now you know that alpha particles are very ionizing, not very penetrating, and a smoke detector uses both of those characteristics. So this is your source inside your detector. It's firing off alpha particles, and there's a small gap between that source and a detector. Now, as long as alpha particles are being emitted, what they do is they ionize the particles between the source and the detector, and those ionized particles hit the detector and they create a current. As long as the current is moving through the circuit inside your smoke detector, nothing happens. If I set something on fire and move some smoke now between the alpha source and the detector, smoke particles, solid smoke particles, are enough to block the alpha particles, to block the ionization of the particles between the source and the detector, and that sets off an alarm, so it starts beeping. Okay, that's a nice example of the use of an alpha source. And it also, by the way, says that you should be very careful how you dispose of your smoke detectors when you're not using them anymore, because they could contain americium-241, which has a half-life of, I believe, something like 400 years. Okay, here's another nice example. This is a beta source. or a beta particle emitter. Here's the beta particle emitter, and here's the detector. Now this is used in paper manufacturers. So what the paper manufacturer does inside the factory, they're putting paper pulp, which is kind of a messy sludge of wood fibres and other things. And to make the paper, they squash the paper pulp between two big heavy rollers. Now these two rollers press too hard down on the paper pulp, the paper that comes out will be too thin. If they don't press down hard enough, then the paper comes out too thick. So this is an example of a nice feedback mechanism. What happens is the detector is connected to the rollers. Here, beta particles are being emitted. Now you know that beta particles are slightly absorbed by paper and they are absorbed by aluminium foil. So if the paper is too thick, too many beta particles will be absorbed and not enough will get through to the detector. If the paper is too thin, too many beta particles will go through the paper and hit the detector. The detector is constantly feeding back to the rollers to tell the rollers either too many particles are coming through or too few beta particles are coming through. So the rollers are constantly moving closer together, further apart, closer together, further apart. It's a nice example of actually something called a negative feedback mechanism in electronics. Okay, hope that made sense. That's a beta source, paper mills. Uses of gamma radiation now. Well, before I move on to this one, a nice use is in sterilization. So things like your packaged cheese and your packaged meats, ham, things like that. What they do is they package them. Those packets will contain bacteria, microbes, fungi, other things that could make the food go off. So in the factories, they pass the packaged food along a conveyor belt. Above the conveyor belt is a gamma source, and the gamma source zaps your food with gamma radiation. Now, a lot of people who are a bit ignorant will then think, so the cheese that I'm eating is therefore radioactive. And of course, you know that's not true. All that's happened is that the radiation, the high energy radiation, has passed through the food. It's not left any sources of gamma radiation behind, but it's got enough energy to zap the microbes, the bacteria, and the fungi that are inside that packaging, so the package is now sterile. Similarly, it's also used in hospitals and other places to sterilize things like scalpels and surgical equipment, so that you can be confident that once it's been zapped by enough gamma radiation, it's sterile to use in surgery. Here's another nice example. This is, well, let's say this is industrial pipework, maybe. It could even be underground. And you want to find out if there's a leak in this pipework. There is actually a leak there, you can see. So you'd use something called a radioactive tracer. And for this, gamma radiation is the best type. So you drop some gamma radiation upstream into your pipework so that it's flowing through, and the liquid flowing through your pipework now contains a gamma source. You've injected it with a gamma source. So the gamma source is inside the pipework. You'd use usually a short, very, very short half-life gamma source, possibly hours, days, depending on how long you've got to try and detect this leak. All of this liquid has gamma source in it. It's emitting gamma radiation. But here where the leak is, there's much more gamma radiation being emitted towards the surface because the leak is close to the surface. So you come along with your detector, you move along, and when you reach the part where the leak is, you get an alarm on your detector, or you get more radiation hitting your detector, your possibly a Geiger Muller tube, and you know that this is the point where your leak is. Okay, that's called the use of a radioactive tracer. Okay, and then the final thing I'd like to cover, a couple of things actually, is nuclear medicine. Now, I don't know if any of you are considering becoming doctors, but if you are, this is a very, very important growth subject in medicine, the use of radioactivity in medicine. I'm not talking about the use of X-rays here, by the way. So here's one use. This thing is called a gamma camera. It's another example actually of the use of a radioactive tracer. So this person, let's say, has a tumour, possibly a brain tumour. So what they do is they'd inject into the bloodstream a radioactive tracer. A very commonly used one is technetium. Depending on what kind of tumour they're looking for, they might use iodine or cesium. Gamma emitters. They flow through the bloodstream, and these sources, again, the sources of gamma radiation, they accumulate in tumour tissue. So if this guy has a tumour in the brain, the radioactive gamma source will accumulate in the tumour in the brain, and when his head is photographed or imaged using this gamma camera, you can see where those gamma sources have accumulated, and then doctors can very accurately, precisely locate where that tumour is located. Which brings us on to the next thing: how do you get rid of that tumour? Well, in the old days, they'd cut you open and cut out the tumour physically. These days, what can happen is you can use something called a gamma knife, where you basically focus a very strong beam of gamma radiation from the outside, so it just hits the tumour precisely, and you zap the tumour away. So this guy, it's a stock photograph. Despite the big smile on his face, he's pretending to be about to be zapped in very specific locations on his head by gamma radiation, which will destroy the tumour. That's a huge step forward in medicine because it means there's no need for invasive surgery, especially dangerous on the brain. You can basically just zap it without cutting open this guy's head at all. Okay, that's by the way, that's an example of radiotherapy, use of radioactivity to kill cancer cells. Another type of radiotherapy is called brachytherapy. I've got a little bit of knowledge about this because my dad had a tumour recently, a prostate cancer tumour, and he was treated by brachytherapy. This is a case where you don't have the radiotherapy zapping you from the outside. What they do is they put the radiation source or the radioactivity source inside the body. So in my dad's case, they took a gamma source, I believe it was a gamma source, about the size of a grain of rice, and they inject it under the skin. And in his case, they left it there for, I think, a week or maybe more than a week. So he was walking around all this time with this small grain of radioactive material inside his body that was zapping the tumour with radiation and zapping it away. So brachytherapy is a different type of radiotherapy where the source is actually put inside the body for some amount of time. Obviously, in all of these cases, radiotherapy, you need to very, very accurately locate the part of the body you're zapping. You don't want to kill good tissue, you're trying to kill the tumour tissue alone. Okay, so I think that's about as much as I need to cover. You've got examples now of alpha sources, beta sources, and gamma sources being used in various ways. Hope everybody's well. I will upload this with some work for you to take a look at, and then in the coming weeks we'll start concentrating more, instead of knowledge, on application of that knowledge to questions or past paper style questions. Okay, take care everybody, and I will speak to you soon.